Hello everyone. We are now going to go over the bone marrow flow cytometry from a 65-year-old man with leukocytosis and numerous circulating blasts. Let's start with CD45 versus site scatter. The population painted in red are the lymphocytes, which express the brightest CD45 with low site scatter. And the population that is painted orange are in the monocyte gate. They sit just above the lymphocytes. They have similar intensity of CD45 compared to the lymphocytes, and they have slightly higher site scatter than the lymphocytes due to minimal granularity. And the population painted in green are the granulocytes, which have the highest site scatter, and they have dimmer than lymphocyte and monocyte CD45 expression. And there are cells in the blast gate, which are painted aqua and maroon, and the blast gate is defined by a dimmer CD45 and low site scatter. And these cells seem to be continuous with the monocyte gate and kind of merging with the population that are painted orange. Now let's track these blasts and see what they express. In site scatter versus CD34, we see that the population expressing bright CD34 is painted as aqua. So these are blasts because of their immaturity marker CD34, and they also express CD38, and they are negative for CD56, they're negative for CD15. They have a partial HLA-DR expression, they're negative for 123. They have a partial dim CD7 expression. They express bright 117, they're negative for 71. And in the next tube, so in this tube, we see that they're positive for 34, 38, and 117, and partial HLA-DR. So basically immaturity marker and one myeloid marker, which is 117. Now in the next tube, we'll see that these 34 positive cells are painted in maroon, and they're kind of continuous with these crimson and the orange population. These blasts are negative for 11B, they're positive for 13, so another myeloid marker, 13. They are partially positive for 33, another myeloid marker. 14 and 64 are hard to assess without the monocytes to compare, so let's defer to the additional scattergrams that are here. We can compare them with the monocytes and decide their positivity. CD10 is negative. So CD33, we know that the the brightest expression is on the monocytes. So the monocytes which are painted orange express the brightest CD34. And then there is a population in crimson here, which has kind of variable 33. I misspoke as 34. So monocytes have the brightest CD33, and the crimson population, which has a variable CD33, is kind of continuous with the orange population, which are the monocytes, and they kind of go and merge with the blasts, which had a partial CD33, if we remember. And the blasts had partial HLA-DR, we see that, and the brightest HLA-DR are positive on the monocytes, which are the orange, and the crimson population is also positive for 33 and HLA-DR. And 11B is positive on the monocytes, and 11B is also positive on the granulocytes. The blasts are negative for 11B, and the crimson population has kind of variable CD11B. This is the most helpful and interesting plot, CD14 versus CD64. Now, CD14 will be positive in the mature monocytes, and they can be positive from the pro-monocyte stage. They kind of will be variably positive. They're brightest in the mature monocytes. CD64 is positive in the monocytes throughout their maturation. So now in CD64 and 14, you'll see the pattern of a mature monocytes here, and there are cells that are acquiring CD14 slowly. They're already CD64 positive. So you have a population of immature monocytes. So basically this crimson population are immature monocytes, and these 1464 bright, these cells in the orange are mature monocytes. Now let's go back a little and see if that matches. The crimson population has HLA-DR because monocytic precursors also express HLA-DR, and they express variable 11B. So they kind of acquire 11B and then become mature. And they are also positive for CD33, similar in intensity to the mature monocytes. So we see that this is a population of mature monocyte. You have a population of immature monocytes, and there is a population of blasts which express 117 myeloid marker. So We deferred CD14 on the blast for these plots. So here we can see that our blasts are CD14 negative, CD64 is partially positive. And this is a 13 versus 16 plot. Here are our mature granulocytes or the neutrophils. And here again are the mature granulocytes which express right 11B and CD16. This is again CD13 versus 64. We can see that in the 64 positive population also has CD13 because monocytic mature monocytes usually have CD13. So we can see that. And our blasts are also CD13 positive. So overall, we have a blast population that is expressing myeloid markers, that is 117 and CD13, and partial CD33 and 64. Our blasts did not express CD14 or 11B. CD64 is not very specific for monocytes. They are kind of brightest in the monocytic lineage blast, but it's not specific for monocytes. And also we only have one marker, so we cannot call our blasts as monoblasts. So we have myeloid blasts, and this blast is continuous with an immature monocyte population that has CD64 expression, HLA-DR, CD33, and it is partial positive for 11B and 14. And we have a population of mature monocytes. So we have a myeloid blast that are going in towards the myeloid maturation, and there is a subset of blasts that are going in the monocyte lineage of maturation. So this is an acute myelomonocytic leukemia picture, and in this particular case, fish studies were positive for inversion 16. So inversion 16, if you remember, is one of those AMLs with recurrent genetic abnormalities, and they are the ones that are associated with those abnormal eosinophils with purple granules. And these usually present as acute myelomonocytic leukemias, and we don't need 20% blasts on these also. And they can have various presentations. For example, some cases will just have mature monocytes and myeloid blasts. Some cases may have mature monocytes, immature monocytes, monoblasts, and myeloid blasts. Some cases can have just myeloid blasts, immature monocytes, and mature monocytes, just like what you have. So basically, you have to remember that it will be like a myelomonocytic leukemia, and you will see a spectrum of population here in the monocytic and myeloid lineage. So when you sign out this case, obviously from flow cytometry, you cannot say that this is AML with inversion 16. Obviously, you need your fish studies for that. You're going to say just acute myelomonocytic leukemia, or you can just say acute myeloid leukemia, and then you can mention what subtypes of population you see, and like you have this much percent myeloid blasts, I see this much percent immature monocytes, and these many mature monocytes consistent with an acute myelomonocytic leukemia correlate with fish studies. So this is another AML with recurrent genetic abnormalities. Thank you.